Carved by water. People often assume that rocks become balanced after falling on top of each other. But that wasn't the case for these marshmallow stacks. There's nowhere the balanced rocks could have rolled from above. Instead, scientists think these balanced rocks were probably carved by water. As rivers cut gullies into the granite bedrock beneath the desert floor, water chews away the weaker types of rock, leaving only the stronger behind. Imagine a house built of strong bricks and held together by weak cement. Bedrock often has these strong and weak parts, although they aren't always visible. If the house is continuously exposed to running water, the cement will gradually wear away, but the bricks will remain. And some of the bricks will be left stacked or balanced on top of each other, like the granite marshmallows in the gully. Rood thinks that most of these rocks were carved out during the last ice age. There was a lot more water, he says. There were big lakes all over the Mojave Desert. If that's true, it would mean these rocks have been standing like bowling pins in the desert for 15,000 to 20,000 years, 4 or 5 times longer than the pyramids of Egypt. Sunburned rock. Rood and Richard planned to test this age estimate. Late one afternoon, a couple of days after their walk through the Marshmallow Gully, they find a refrigerator-sized boulder that looks ready to roll downhill. Unlike a lot of the other balanced rocks they've seen, this one is on the side of a small mountain, in a place where it could have landed after rolling from somewhere higher up. But Richard and Rood have a way of knowing that it didn't. They can tell, in fact, that it's sitting within a few centimeters of where it was eroded out of the surrounding bedrock. Rood points out a vein of brownish quartz crystals, several fingers thick, that run through the bedrock a few meters behind the rock. That layer runs for 30 meters before disappearing. It is tilted, like the hour hand of a wall clock at 8 o'clock, but otherwise straight as an arrow. That same layer of quartz runs through the boulder. It is perfectly lined up with the layer in the bedrock. It would be a pretty unlikely coincidence if the boulder just rolled down the mountain and landed that way. This rock has to be sitting in its original birthplace. Rood hangs a tape measure down the boulder, which is 6 feet tall. He hammers a small piece off of the boulder every few inches from top to bottom. Back at the lab, he'll test these bits of rock to see how long each part of the boulder has been exposed to sunlight. Rood measures this by using an accelerator mass spectrometer, a monster machine the size of an 18-wheeler. He'll use this machine to measure tiny amounts, a few quadrillionths of a gram, of a rare radioactive form of the element beryllium. This rare form, called beryllium-10, is created when cosmic rays from space hit the rock and split apart larger atoms of oxygen and nitrogen. You might say when this happens, the rock is getting sunburned. As long as the rock is sitting out in the open, the cosmic rays are hitting it, and beryllium-10 is forming in the outer 2 or so centimeters of the rock. But while the rock is buried underground, before running water chews it out of the desert floor, it's shaded from cosmic rays, so no beryllium-10 develops.